be covering living tissues and photosynthesis. Okay. So you have to be prepared to answer questions from the lessons living tissues and photosynthesis, which are the first two lessons. Is that clear to you, Lamai? Give me a thumbs up if it's clear.
Creative.
Okay. All right. මොකද පරණයව මතක නැත්තම් අපි කොච්චර අලුත් ඒවා ඉගෙන ගත්තත් වැඩක් නැහැ. Okay, Risindi, okay. Date you're talking about the geometric optics, light lesson. Did you send the day? Well, I have. Okay, I'll check with her. I'll check with her for sure. Okay. Convex lenses. All right, we have talked about the focal length. Sorry, focal point. Okay. Now, we are going to be drawing ray diagrams today. Harida. So before, if you remember in mirrors, before we drew the ray diagrams of how images are formed, we learned about the basic reflections, right? We first learned the basic reflections, right? So here also, what we are going to do first is we are going to be learning the basic reflections. Once we are done with the basic reflections, we are going to be looking at how images are formed. Okay. So put a subtopic. Basic reflections. Under convex lenses में थमाई put a subtopic basic reflections. Recently, can you do something? Will you be able to give me a call tomorrow at around 10? No, 10, 11 වගේ වෙලාවට? Can you give a call to my personal WhatsApp number? Ude, AM. While in the call, I will arrange the recordings. නැත්තං ඕක හරියට කෙරෙන්නේ නැහැ. Okay? So make sure you definitely give me the call. 10:30, 11 වගේ වෙලාවට දෙන්නකෝ. And during the call itself, I will arrange the recordings. Let's do that. Otherwise, it's not happening. Okay. Basic reflections. Then අපි දන්නවා how this works, right? Okay. So we have the principal axis. I'm sorry for the call earlier. We have the principal axis here. Okay. And you already know what the principal axis is. And then here we have our lens. If you remember, Lama, in mirrors, since, if you want the mirror to be very big, large, it would be inconvenient to draw concave or convex mirrors with a curve as a large mirror. Therefore, what we did was we drew like a dash line and we said that this dash line represents the mirror, right? The same thing we are going to do in lenses, where we are going to assume that main dash line එකෙන් මුළු lens එකම represent වෙනවා, right? Just to show whether it's a convex lens or a concave lens, I will draw the shape like this. හරිද? ඒක තේරුණාද? So this entire thing represents the mirror and this is the principal axis. Is that clear to all of you, Lamai? Others?
Yes, teacher.
Okay. Now let's go ahead with our first basic reflection. I have a question. What is this point called? What is this point called?
Principal axis?
No, the point.
The point, teacher.
Yeah, the point.
Focal
yes.
point?
No. C. Okay, what is C?
Center.
Not center. Met me, I can't hear you. Well, I can hear that like a slight sound. Ashwita, you said center, no? Center not complete. Mayumdi, yes. And I'm getting answers in the chat box too. Center of curvature anyway. Center of curvature is in the mirrors. Yes,
Optical center.
Optical center.
Optical center, yes. Yes, with me. Yes, Ashwita, it's optical center. Mayumdi also, yes. Center of curvature is a term we use in mirrors, not in lenses. Okay? Right. දැන් මොකද වෙන්නේ? First reflection එක මෙන්න මෙහෙමයි වෙන්නේ.
Teacher,
Yes, Ashwita.
your voice is low, teacher. Like, I cannot hear it.
Yeah, let me check. Right, I will increase it a bit more. How about now?
Now okay, teacher. Before it was so low.
Right, okay. Now you can hear it.
Yes.
Okay. So, first ray එක තමයි you send a light ray towards the optical center like this. Well, optical center එක through යන light ray එකක් යවුවම when it is, I mean, it's a lens, so it will be refracted. When it is refracted, the light ray will not bend. එයා bend වෙන්නේ නැතුව ඒ ආපු path එකේම යනවා මෙන්න මෙහෙම. That's quite special because as we have learned, if it's a transparent medium, the light ray has to bend during refraction. However, if the light ray is going through the optical center, the light ray will not bend. එයා ඒ path එකේම කෙලින්ම එක දිගටම යනවා. I'll show you another light ray. Let's say මෙහෙම light ray එකක් යනවා කියලා optical center එක through. එයා ඒ path එකේම බොහොම දිගටම යනවා. Right? Without bending. Refract වෙනවා. Refraction means going to the other medium, but එතන bend එකක් වෙන්නේ නැහැ. This is our first basic reflection. Okay, second one is, we already learned this last week. When you send a parallel light ray, this will be refracted. That means it will bend. When it is bending, it will bend inwards and go like this. And this point is the focal point of the lens, right? As we discussed last week, when you send a parallel light ray that is parallel to the principal axis, it will be refracted, of course. And when it is refracted, it will go through the focal point on the principal axis, right? මම තව එකක් පෙන්නන්නම්. ඔන්න මෙහෙම another parallel light ray is going like this. And this will also reflect through the focal point. Like this. Okay. Then our third basic reflection. We only have 3 basic reflections here. Third එක තමයි second එකේම opposite එක. What is that? If you send a light ray through the focal point, it will be refracted parallel to the principal axis. In the second one, when you send a light ray that is parallel to the principal axis, it will be refracted through the focal point. Here, when you send a light ray through the focal point, it will be refracted parallel to the principal axis. මේ තුන විතරයි තියෙන අපිට basic reflections. We are going to use only these 3 to formulate all these images හදන විදිය objects වලින්. ඒක අපි හොයන්නේ මේ තුනෙන් විතරයි. Okay? So are the basic reflections all clear to you, ළමයි? Give me a thumbs up.
Yes, teacher.
Okay. Can you all quickly draw this? Please make sure that you draw the arrowheads of all the light rays, because without arrowheads, you don't get marks. ඔයගන්ට ඕන නම් මේ basic reflections වල you can use like a red color to draw the light ray, but it's not really necessary. It's only optional. Yeah, make it fast. Lamai, I'll give you 3 more minutes. Let's quickly finish this lesson today. Waves අපි දවස් waves note එක print out අරන් ඇති නේද ඔයගොල්ලන් because I sent it quite a while back. Waves එකත් අපි weeks දෙකක් වගේ අතට ඉවර කරන්න ඕනේ somehow because we have the PDF. I think that will be easier because we are coming after that. We are going to the longest lesson, one of the longest lessons of the syllabus, the biology lesson.
Teacher, usually like they say us to do O-level past papers, no?
Yeah.
Like for how from which year to which year should we practice like
Um,
papers?
Usually in our past paper revision, we are going to do from 2016 onwards because I mean that might feel like a lot, but still a practice එක අනිවාර්යෙන් තියෙන්න ඕනේ because the new syllabus that y'all are using now started in 2016. I was actually the first batch of the new syllabus, so you can guess my age. So 2016 වල තමයි yeah 2016 තමයි first batch of the new syllabus, and our papers were very easy. If you check, I mean, when we are doing the papers, because even the previous batches, when we were doing papers, they were all like, Miss, you're so lucky. Because actually, the science paper is quite easy. I think most of the papers were considerably easy compared to the papers that followed up in the coming years. But yeah, we have to do from 2016 until the most recent paper. It can have a bit of 5 years වගේ අහුවෙනවා. Sorry, 9 years වගේ අහුවෙනවා.
Okay, teacher.
ළමයි 9 years නෙවෙයි, sorry 10 years නේ. 10 years නේ because this is 2016, 2026 නේ. By the way, did you all finish this? Okay. Anybody who needs more time? Anybody who needs more time? No. All right. Now we start the image formation. This is again one of my favorite parts. My light lesson එකට හරියම කැමති because I love drawing ray diagrams. So here we will put a subtopic as image formations. Image formations කියලා subtopic එකක් දාන්න. Now don't write anything and just listen. Listen. Board එක දිහා බලන් ඉන්න කොහොමද මේ rays යන්නේ කොහොමද මෙතන ළමයි a small corrections here. This is not basic reflections, basic refractions. Please make that change. I'm sorry for that, but please do make the change. Anyways, so බලන්න කොහොමද light එක refract වෙන්නේ කොහොමද අපි basic reflections use කරන්න කියන එක හොඳට focus කරලා බලන්න. ඊට පස්සේ මම ඔයාලට වෙලාව දෙනවනේ ලියන්න sorry අඳින්න වෙලාව දුන්නාම try to write it alone, draw it alone. ඊට පස්සේ පොඩ්ඩක් board එකත් බලලා but අර එක හොඳට understand කරන ගමන් draw කරන්න. Right? Because a lot of students say lesson is difficult, but it's not that difficult. It's just that you're not understanding the concept. Basic reflections, basic refractions තුන මතකයි නම් ඕනෙම ray diagram එකක් ඇත්තටම අඳින්න පුළුවන් ඔයගලන්ට. හැබැයි most of the students are like so obsessed with memorizing. හැම එකක්ම කටපාඩම් ගිරවෙක් වගේ කටපාඩම් කරන් තමයි practice වෙලා තියෙන්නේ. එහෙම කරන්න බෑ of course light. මොකද එහෙම කරොත් ඒකට වෙනම space එකක් වගේ ඔළුවේ වෙන් කරන්න වෙනවා. අනිත් ඒවාට ඒක ඉඩ නැති වෙනවා. That's how it is, right? We all have a brain capacity. So මේ වගේම strategically smart විදිහට කොහොමද පාඩම් කරන්නේ? Basic refractions ටික මතක තියාගන්න. ඔක්කොම ray diagrams වල අපි basic refractions තමයි use කරන්නේ. That is why they say don't study hard, study smart. All right? So එකින්ද හැමලෙම ඔයගොල්ලෝ මෙතන focus කරන්න ඕනේ. How are we using these three basic refractions for all our image formations? Our concave mirror එක වගේ object is between the lens and the focal point, object is on the focal point, object is between this and that. එක locations අපි බලනවා. එතකොට හැම වෙලේම කොහොමද basic refractions ටික use කරන්න කියලා ඒකට focus කරන් බලන්න. All right? Okay. So, මේ තියෙන අපේ principal එක මම චුට්ටක් මේක දෙපැත්තෙන් දික් කරන්නම් so that we have more space to work with. And you all know, unlike a mirror, in a lens, දෙපැත්තෙම focal points දෙකක් තියෙනවා. ඕගලන් දැන් draw කරද්දී straight lines draw කරන්න ඕනේ, so you please use a ruler. And one second. හරියටම optical center එකේ ඉඳන් you have to measure a certain distance. I'm going to measure 3 squares and I'm going to mark my focal point. That same distance I'm going to mark on the other side. So here also 3 squares and I'm going to mark the focal point. Okay. ඊළඟට මෙතන දැන් අරක තිබ්බනේ focal point and center of curvature කියලා F and C කියලා. In the lenses we don't have a C. Instead we have මේ වගේම දැන් මෙතන 3 squares තියෙනවා. ඒ වගේම distance එකක් අරගෙන මෙන්න මෙහෙම තියෙනවා. We call this 2F. ඒ කියන්නේ it's like double the distance of focal length. If the focal length is 10 centimeters, here also it should be 10 centimeters, something like that. Okay. So sometimes you can write it as 2F or sometimes you can even write it as F dash. Textbook එකේ තියෙන F dash නේද? Papers වලදී ළමයි you get both 2F or F dash. So F dash කිව්වහම that means double the distance of the focal point. Up to that point, did you understand what I said? Thumbs up. Okay. Now, කොහෙද අපේ object එක තියෙන්නේ? Object is between the lens and the focal point. Okay, so here we have the lens. Here we have the focal point. එතන මැද තමයි object එක තියෙන්නේ. So I shall draw my object here. This is my object. Now I have to draw our ray diagrams. From the basic reflections where we learnt 3 ne. ඒකේ මම use කරනවා first එකයි second එකයි. First එකේ තියෙන optical center එකට යන එක නා ඒ path එකේම යනවා, right? So I will use that. Object එකේ head එකෙන් යන්න ඕනේ obviously. Optical center එක through යන එක නා refract වුණාම තේ path එකේම යනවා. ඔන්න ඔහොම තමයි කරේ එක. This is the basic refraction one, na? Optical center එක through යන එක නා ඒ path එකේම යනවා. Okay. Then for the other, because we need at least 2 light rays, ne? For the other light ray, I'm going to use my second basic refraction. There, when you send a parallel light ray, it will be refracted through the focal point. So I'm going to send a parallel light ray that is obviously going through the head of the object. This light ray is parallel to the principal axis. When it is refracted, it will be refracted through the focal point as such. Okay. And we know, just like mirrors, in lenses also, where the image is formed is where the 2 refracted light rays meet. Mirrors will reflect when a light rays then meet when a image. In lenses, refract when a light rays then meet when a So this is one of the refracted light rays. This is another refracted light ray. So ඒ දෙන meet වෙන තැන තමයි image එක හැදෙන්නේ. Do they meet at the front of the mirror? What do you think? No, because they are going further and further away from each other. එහෙනම් මොකද අපි කරන්නේ? In order to find the image, what do I do next? You all know this. Yes, what do y'all do? Yes, we are going to extend the light ray backwards. If the refracted light rays are not meeting at the front, we have to extend them backwards. Give me a second. Okay, so I will erase these two lines. Now let's extend this backwards. Monkey now when we're extending these backwards, that is the same side as the object, right? ඒ කියන්නේ අපි දැන් light ray එක සමන ඉස්සරහටනේ යන්නේ. ඉස්සරහට යන light ray එක අපි පිටිපස්සට extend කරනවා කියන්නේ we are just extending imaginarily. It's not actually there. So of course we have to use dash lines. දැන් මේ එක refracted light ray එකක් මෙයා මම ඔන්න පිටිපස්සට extend කරා. This is another one. This is our other refracted light ray. අවත් මේ පිටිපස්සට extend කරා. Like this. Now we can see where they meet. This is where they meet. ළමයි object image එක object එකේ side එකේම හැදෙනවා නම් we call this image a virtual image. Therefore, I use dash lines to represent the image. Okay, which means now let's say object okay, let's say this is an object and let's say this is my lens, right? So my object එක මම lens එක through බලද්දි through the lens I can see the image. That is what this means, right? හැබැයි මේ අනිත් පැත්ත image එක හැදුනොත් through the lens I can't see the image, then I have to use a white color screen. That's more or less the same story as mirrors. Okay, so this we call a virtual image because you can see the image through the lens. Okay. First, did you understand the ray diagram before we discuss the rest? Back and front of okay, that's a very good question. How can we identify the back and the front of the lens? Because if it's a mirror, that's obvious, right? Mirror එකේ front එකයි back එකයි obvious. Lens එකේ දෙපැත්තම එක වගේනේ. Usually when we're drawing a ray diagram, අපි back එක කියලා කියන්නේ object එක තියෙන පැත්ත. Front එක කියලා කියන්නේ අනිත් පැත්ත. Right? So in this, but I mean, usually lenses වල අපි front back කියන terms දෙක use කරන්නේ නැහැ. But to understand, we can say that object එක තියෙන side එක like can be considered the back of the lens. This can be considered the front of the lens. But better not to use those two terms when we're writing answers. Is it clear, Mitna? Okay. Hari, my ray diagram එක අනිත් හරිය clear නේද හැමෝටම? Okay, great. If you have further questions, please do ask ළමයි. අපි ලියමු. Location of the image. Now object එක තියෙන side එකේම තමයි image එකක් තියෙන්නේ. So we say on the same side of the lens as the object. Then properties of the image. Okay, I told you if the image is on the same side as the object, we call it a virtual image. Is this an upright image or an inverted? Yes, good. It's upright. What else? Magnified or diminished or equal size? What do you think? Good. Magnified. Magnified, which means larger than the object. Yes. So these are the properties of the image. Okay, now quickly write this. First draw this very clearly. Make sure that you draw it clearly. Draw all the arrowheads. Double check once you are done drawing. And automatically yaga. Quickly. Lamai, I'll set a timer for 4 minutes. Timer එකක් තිබුණ නැත්නම් you literally do it නේ. So ඔබට timer එකක් තිබ්බම ඔයගලගේ speed එක හරියනවා. I mean, I'm setting the timer for 4 minutes now. I mean, all this time you have been drawing, so I think 4 minutes is enough. Quickly draw. Done, lamai? You have a little more time.
Teacher done.
Okay. Am I done? Done or not, we are going to move on. Okay. Okay. Then our second instance where just look at the board. So we have our convex lens, we have the principal axis and all that. Okay. So I will mark the focal point. 3 squares gila focal point එක. තව 3 squares gila f dash, which is double the focal length. Here f and here f dash. You have to measure correctly, otherwise you will not get it correctly. I mean, you will not get the image correctly if you don't measure and write. Then where is our object? The object is on the focal point. On the focal point, which is here. Okay. Now this is pretty easy. Basic reflections, දෙකක් මොකක් හරි use කරන්න. Right? Mama use කරේ first එකයි second එකයි. If you want, you can even use the third one. First එකයි third එකයි පුළුවන්. Second එකයි third එකයි පුළුවන්. Whatever the basic refraction you use, the result should be the same. Hi, first light ray on optical center through මෙහෙම යනවා. Optical center through යද්දි the light ray is not bending. It will refract as it is. That's my first ray. Next one, I'm sending a parallel light ray. A light ray that is parallel to the principal axis, and we know when this is refracted, it will refract through the focal point. As such. So, what are our refracted light rays? This and this. Are they meeting at the front of the mirror? Are they, do they seem like they're meeting at the front of the mirror? No. Do you think they will meet at the back of the mirror? I mean, we can, mirror නෙවෙයි ළමයි, I'm sorry, the lens. We can extend and check. How extend වෙන්නේ? Like somewhat like this, ne? Front or back, the two light rays seem to be parallel to each other. And we know in mathematics also we have learned parallel lines, they don't meet ever. ඒගොල්ලෝ කොහේ හරි meet වෙනවා නම් it is a imaginary location called the infinity. And these our light rays, they are also parallel. එහෙනම් අපි කියනවා okay, they will meet somewhere, but it's far away, it will be at infinity. ඒකින්ද එතන තමයි image එක හැදෙන්නේ කියලා අපි කියන්නේ. Right? So we say just, I mean, you're familiar with this now. මොකද අපි concave mirrors වල මේක කරා. The location of the image is at infinity. So properties of the image I will just give, you will have to memorize because image එක අපිට draw කරන්න බෑ. So you will have to memorize. So this is going to be a real image. Real image කොහොමද එන්නේ කියලා මම ඊළඟ ray diagram එකේ කියා දෙන්නම්. But for now, just write it. It's going to be an inverted image and it's also going to be a magnified image. Is this clear to all of you, Lamai? Give me a thumbs up, please. Okay. Can you quickly draw? Mama make it then 5 minutes, 4 minutes? Let's see. Let's try to do within 4 minutes quickly. Okay. Let's move on to the next ray diagram. I hope you have finished drawing this, no? Finished there. Give me a thumbs up. You guys are not very responsive. As in, you have to respond. We have to communicate. You have to ask questions. You have to answer my questions. මම උගන්ට අත්තටම කියන්නේ ලේසිම කරලා දීලා මම thumbs up එකක් use කරන්න කියලා ඒත් ඔයගලන්ගේ responses මදි. thumbs up එක දෙන්න කිව්වමත් කීප දෙනයි දෙන්නේ. I mean, if so, here's the thing. I'm asking if everything is all right. If everything is all right, you give a thumbs up. But if you can't give a thumbs up, that means something is not right. Then you have to ask me. Okay. මොකද මට one by one හැමෝගෙම thumbs up කාගේද ආවේ කාගේද නැති කිය I can't like one by one check. That's going to consume a lot of time. So be responsible for yourself. Okay. So make sure that you have everything clarified. You have no idea. අන්තිම කාලෙදී අත්‍තරම clear නැති points තිබ්බොත් අන්තිම කාලේ අත්‍තරම ඒ කාර්යම annoy. And a clear නැති points උඩින් තව clear නැති points එහෙමම ගොඩාක් clear නැති points එකතු වුණාම ඒවා clear කරගන්න you have to give an extra effort. That is totally unnecessary. I'm talking with like දැන් මං කියවනේ දැන් batches 5කට 6කට විතර ඔය same scenario වෙච්ච ළමයි ඕන තරම් මම දැකලා තියෙනවා. Right? මම කොච්චර මෙහෙම කිව්වා some of you, most කියන්න බෑ, some of you are still going to wait until it is the absolute last minute to do everything. හරිද? ඒක වෙන එක ලොකු ප්‍රශ්නයක්. So even now you have plenty of time නේ. තාම March නේ. March is over and now it's April. Even now if you take it slow, you will still have time. නැත්තම් අන්තිම කාලේ rush කරන්න ගියොත් එම හරි අමාරු වෙනවා. මොකද මං ගාවට students ඇවිල්ලා තියෙනවා even like August, September වගේ last minute cover කරගන්න. ඒ කියන්නේ මුළු අවුරුදු එකමාරක් විතරම slack off කරලා වැඩ හරියට කරන්නේ නැතුව අන්තිම මොහොතේ කොහොම හරි O level ගොඩ දාගන්න කියලා එහෙම ආපු ළමයි ඉන්නවා. So some of them have gotten A's and B's, but it's a lot of work. මම දැකලා තියෙන ළමයි කොච්චර stress වෙනවද කියලා. අන්තිම කාලේ ඔක්කොම කියන්නේ I mean science විතරක් නෙවෙයි තව subjects 8ක් තියෙනවනේ. ඒත් ඔක්කොම කරන්න ඕනේ අන්තිම I mean ඇත්තටම මට සමහර ළමයි ගැන පව් කියලාත් හිතනවා එහෙම ඔක්කොම එකතු වුණාම හරි අමාරුයි. ඒක මම S දෙකෙම දැකලා තියෙනවා මට හතරම පව් කියලා හිතෙනවා. ඒත් I can't really justify මොකද you have to be responsible නේ. ඒ ළමයි දැනගන්න ඒ ළමයි responsible වෙන්න ඕනේ එයාගේ situation එකට. Because you guys are not kids now. now ගන්න දේවල් තේරෙන වයසකනේ ඉන්නේ. එතකොට මම කියන්නේ ගියේ මම අන්තිම මොහොතේ ඔක්කොම cover කරගන්න ළමයි නැතුව නෙවෙයි. හැබැයි full potential එක ගන්න අමාරුයි. සමහර A එකක් ගන්න පුළුවන්කම හොඳටම තිබිච්ච ළමයි got a B. I can මම කියන්නේ last minute cover කරගන්න ඉන්න ළමයින්ට. Right? Full B එකක් ගන්න පුළුවන්කම හොඳටම තිබිච්ච ළමයින්ට got C. එහෙම ළමයිනුත් ඉඳලා තියෙනවා. Because I'm not a god, right? අන්තිම මාස 4-5 මට කිව්වොත් එහෙම teacher miss මට මේ ගොඩ දාලා දෙන්න. එහෙම කියලා I will try my best. I will give my maximum, but still I'm not God. I can't create miracles. Because you know the science syllabus is massive. So ඒක හින්දා little by little දැන් ඉන්න චුට්ට කරන්න, not a lot, but චුට්ට හරි කරොත් things will add up. And මවගන්න හැමලෙම කියනවා වගේ පොඩි දේවල් තමයි කවදා හරි ලොකු දෙයක් වෙන්නේ. Okay? So don't try to do everything at once. Don't try to like do things perfectly. Just do something. Because you know something is better than nothing. Okay? මොකද අර අන්තිම මොහොතේ ඔක්කොම කරගන්නවා කියලා හිතන ළමයි exam එකට කලින් දවසේ හරි exam එකේ වුණාට පස්සේ they have a lot of regrets. ඒගොල්ලෝ හිතනවා අයියෝ තව මාසයක් තිබ්බනම් තව සතියක් තිබ්බනම් එහෙම කියලා හිතනවා. එහෙම regret කරන එක අපරාධනේ because I mean O levels is not like extremely difficult. ඔයාලන් කිසි කෙනෙකුට O levels extremely difficult නෑ because I know all of you can get an A. It is possible. හැබැයි දැන් ඉඳන් කරන්න. ඊට පස්සේ අන්තිම මොහොතේ චුටු ගන්න බෑ. Okay? And especially when we start the past paper revision, මම ආයේ මෙහෙම පාඩම් කරන්න මෙහෙම නෙවෙයි past paper revision එක වෙද්දී අපි past paper revision එක පටන් ගද්දී everything that we have done up to that point, including all the grade 10 and whatever we have done in grade 11, you have to have a very good knowledge, understanding and memory. නැත්තම් past paper revision එකේ මාර්ගදි stuck වෙනවා. Okay? ඊට පස්සේ මොකද කරන්නේ ඔයගොල්ලන් ඒ වෙලේ එදා දවස shape වෙන්න මොකද කරන්නේ marking scheme එකෙන් බලන් උත්තර ටික ලියන් එනවා ඒ දවස shape වෙන්න තමයි හදන්නේ ඔක්කොම වැඩක් නැහැ right because you have to be honest to yourself I mean මම දන්නවා සමහර ළමයි එහෙම කරනවා කියලා sometimes I act like a fool but ළමයි answer කරන විදියෙන් chat box එකේ හරි unmute කරලා හරි උත්තර දෙන විදියෙන් past paper revision කරන කාලෙට මම දන්නවා මේ ළමයා හිතලාද මේ answer කළේ ඔය DP education හරි මොනා හරි YouTube video එකක් බලාගෙන මේ answer කළේ ඔය marking scheme එක දිහා බලාගෙන ලිව්වේ කියලා ටග්ගා කියන්න පුළුවන්. Even when I was doing physical classes, සමහර ළමයි ඇත්තටම homework DP education වල මේ තියෙනවනේ අර DP education විතරක් නෙවෙයි I think there are so many YouTube channels where like they discuss textbook homework. It is good. I mean, ඔගොල්ලෝ ඒකෙන් learn කරනවා නම් ඒක හොඳයි. හැබැයි ඒකෙන් shortcut එක අරන් ඒකෙන් answer කරන් ලියාගෙන ඇවිල්ලා පෙන්නනවා නම් that is not good. I don't know if you all do it, but I mean that's meaningless. නේද? වැඩක් නැහැ නේද එතකොට. ඒකෙන් ඉගෙනගෙන ඊට පස්සේ එහෙමනම් I mean it's okay. So learning is learning. කොහෙන් කරත් learning is learning. But එහෙම ළමයි ඕන්තරමට අහු වෙලා තියෙනවා. සමහර වෙලාවට අර ක්ලාස් එකේ ඔක්කොම ළමයි ඉන්න තැන ඒ ළමයාගේ confidence එක crush කරන්න ඕනේ නැති හින්දා මම එහෙම ක්ලාස් එකක් හැමෝම ඉන්න තැන එහෙම confront කළා මේක කොහෙන්ද answer ගත්තේ. එහෙම මම ගොඩක් අර කියන්නේ නැහැ. But I drop hints, but you know, ඒක දැක්ක ගමන් තේරෙනවා. So my point is, don't treat yourself. දැන් ඉන්න වැඩ කරන්න අර එදා වේල shape වෙන mindset එක හරියන්නේ නැහැ. Not for O levels, not for A levels, right? So ඒකින්ද please work. I'm not asking you again. තාමත් මම ඔයාලට කියන්නේ නැහැ නිදි මරාගෙන එහෙම පාඩම් කරන්න කියලා. Do something every day. I know that some of you don't do anything. Some days ඔයගොල්ලන් දවසෙම science අල්ලන්නේ නැහැ, maths අල්ලන්නේ නැහැ, මොනවා subjects බලන්නවත් නැති දවස් තියෙනවා. I know එහෙම දවස් තියෙනවා. ඔයගොල්ලන් දැන් you can ask yourself. ඒතර ඔයගොල්ලන් දන්නා මම මෙහෙමද මෙහෙම නැද්ද කියලා. Okay? So එහෙම නොවි පොඩි දෙයක් හරි කරන්න because as I say every day little things add up. Okay? එතකොට මම මෙතනත් කිව්වේ අනිත් එක තමයි මේන්ම දේ learning what's being taught to you during the class කියන එක මාරම important. මේක මේ හැමදාම කියන බණ තමයි but I mean still ඔය මොන බණේ කිව්වත් අන්තිමට past paper revision කාලේ and exam kit උනහම I still see the same story. I don't want that to happen. I want you all to perform very well because I know all of you have the potential. Okay? ඒකෙන් දැන් මෙතනත් මම light lesson එකෙත් මම ඔයගලන්ට කියන්නේ try to understand the concept. නිකන් ගිරව වගේ කටපාඩම් කරන්න එපා. If you study like a parrot, if you are like always by hearting memorizing, ඔයගලන්ට හරි අමාරු වෙනවා science paper එක. Science නෙවෙයි I don't know there are certain subjects that require you to memorize like a parrot. But science is not one of them. Okay? එහෙම වුණාම අර science වල අහන්නේ ඒගොල්ලන් concept check කරන්නේ. paper එකේ concept එක තමයි check කරන්නේ. Right? So ඒකින්ද memorize කරන්න ඕනේ දේවල් තියෙනවා but majority is not to memorize but to understand the concept. So please keep that in mind. ඒකයි මම මෙතනත් කිව්වේ while we are drawing the ray diagram focus on how we are using the basic refractions. ඒතර basic refraction එක තමයි ඔළුවට යන්නේ. නැත්නම් ray diagram එක කටපාඩම් කරන්න එක නෙවෙයි. Okay? අන්න ඒකෙන් තමයි මම කිව්වේ අනිත් එක තමයි next week living tissues and photosynthesis I will be checking. If you don't answer I will call out your names. නම කතා කරද්දී class එකෙන් leave වුණොත් I will be calling your parents. Okay? මොකද ඕන තරම් online class එක වෙනවානේ. Online class එක කියලා you can't take the class lightly. Online or physical a class is a class. Teaching is teaching, learning is learning. The only difference is that we are connecting virtually. Okay? හැමෝම උත්තර කියන්න ලෑස්තිලා ඉන්න වැඩි answers ආවේ නැත්නම් as I said I will call out your names. නම කියද්දී unmute කරේ නැත්නම් or chat box එකේ උත්තර දුන්නේ නැත්නම් or ඒ වෙලේ class එකෙන් leave වුණොත් I will be taking action for that. And next week attendance ඇවිල්ලා තිබුණ නැත්නම් මම බලනවා අය attendance ඇවිල්ලා නැත්ද කියලා. Okay, I'm going to be very strict on that. So ඒක ඔයගොල්ලන් අයියෝ ඇයි මෙහෙම කරන්නේ ඇයි එහෙම කරන්නේ කියලා හිතන්නේ නැතුව okay this might be a good chance for me to study කියලා ඒක opportunity එකක් විදිහට අරගෙන first two lessons revise කරගෙන එන්න. Okay? Is that clear to all of you lamai? Give me a thumbs up. Will you be revising the first two lessons and come next week?
Yes, teacher.
Okay, good. Living tissues and photosynthesis. They're both biology. Okay. All right. Mm, then third one. Object is between. Yes, receive me. I don't know. Let's see how time. I think up to chutta khar karan Quran definitely. Object is between the focal length and තව චූටි දෙයක් මම ඔයගලන්ට කියන්නම් මේ last week's දෙක විතර last week's තුන විතර පොඩ්ඩක් recording upload කරන එක irregular වුණා because there was a problem with ඒ කියන්නේ recordings upload කරද්දී there's a quota like storage quota එකක් තියෙනවා so ඒක YouTube එකේ like YouTube එකේ you have to update and upgrade or something like that but it's all good මේ week එකේ ඉඳන් ඔයගලන් මේ ඒ කියන්නේ දැන් classes absent වෙන ඒවා previous recordings also you can request but classes absent වෙන ඒවා දවස් දෙකක් වගේ ඇතුළත you can request and get it okay Miss Divya told me that a lot of you have requested ඒ කියන්නේ absent වුණාම ඉතින් recording එක ඉල්ලනවානේ so සමහරවිට recording එකේ වන්න පරක් වෙනවානේ and that's a problem right but it won't happen again okay object is between the focal length and twice the focal length. So twice the focal length කියලා කියන්නේ අපේ මේ f dash කියන point එක. Okay. So now this is where the object is. So I will draw my object between f and f dash. Like this. All right. Same story. Basic refractions. තුනෙන් කැමති දෙකක් use කරන්න පුළුවන්. I'm using this one where you send a light ray through the optical center and it will refract along the same path. Then I will send a light ray parallel to the principal axis and it will be refracted through the focal point. Like this. Now we have to see where the two light rays meet. මම චුට්ටක් මේව extend කරන්නම් නැත්තම් ඊට පස්සේ wait අහුවෙන්නේ නැහැ. Would this be enough? This also we need to expand a little more. A little more. ඔය ගාන වගේ නේ. Okay, so this is where the image is formed. I will extend my principal axis නැත්තම් අහුවෙන්නේ නැහැ image එක. So this is where the two refracted light rays meet and this is where the image is formed. A straight line like this. This is where the image is formed. Okay. Now, let's take a look at this. Do you think we can see this image through the lens? Lens එක through බැලුවොත් ඔයාට image එක පෙනේද? මට ඒක answer එක දාන්න give me a second. Actually, you cannot see the image through the lens. Then what are the objects that I took here? If this is object and this is a lens, මම මෙහෙම lens එක through බැලුවා කියලා මට මුකුත් පේන්නේ නැහැ. Why? Because the image is a real image. It's formed on the other side of the lens. Then how do I observe this kind of a real image? How do I observe this kind of a real image? based on what you have learned in concave mirrors? Yes. Okay, good. I'm getting answers. On a screen, on a white color screen, white sheet of paper, whatever. Yes. Something like some sort of a screen which is white in color. So therefore we call this a real image. Okay. So let's write location of the image beyond twice the focal. Twice the focal length can මෙතන f dash එකනේ. ඒකරත් එහායින් තමයි image එක තියෙන්නේ. So beyond twice the focal length on the other side of the lens. Okay. Then properties of the image, it's real, it's inverted, and it's magnified. Is that clear, Lamai? Is that clear to all of you? Okay. Then let's draw this. I will set a timer for 6 minutes. මොකද මේකේ වරදින්න හැම දෙයක් වරදින්න chance එක වැඩි දික් කරලා අඳින්න ඕනේ හැමෙමනේ. So I will set a timer for 6 minutes. Quickly draw. I have a question. Don't we indicate the image in dotted lines when it's real? No. So, morning, you indicate the image like in dotted lines like this only if the image is virtual. Real images, because they are real, you draw it as a bold line. Okay, Lamai, time is up. Have you finished writing?
Yes, teacher.
Okay, others? Okay. Fourth one. Excuse me. Okay. So, okay. Now, object is at the point which is twice the focal length. So, twice the focal length can may point again. So, on a may point I draw my object. We have three basic refractions that we have learned. You can use either two of the three that we have learned. So, එකක් තමයි optical center එක through යන එකේන ඒ path එකේම අනිත් පැත්තට refract වෙනවා. අනිත් එක තමයි parallel යන light ray එක focal point එක through refract වෙනවා. Like that. So this is where the two light rays meet. Therefore, this is my image. Okay. So as usual, we are going to write the location of image. This is between focal length and twice the focal length. But on the other side of the lens, right? Lens ke anik pathne diyenne. On the other side of the lens. Properties of image. We can see it's a real image. Yes, correct. Real image because of course it's produced on the other side. So we have to use a white color screen. It's inverted, yes, and it's smaller than the object. We say it's diminished. One second. There's a little problem. Wait. This is not how the ray diagram should be. Mage drawing එක පොඩි ප්‍රශ්නයක් වෙලාද? Because if it's actually I did a little mistake here. If the object is on F dash, images also should be on F dash. කොහොමද මගේ මෙතනට ආවේ? මෙතන straight line එක ගියා optical center එක through ගිහලා මේ පැත්තට ආවා. Then parallel light ray එක මෙතන චුට්ටක් bend වෙලානේ. So like that. හරිනේ එතකොට. Because ළමයි actually they are supposed to meet on F dash on the other side. My bad. ඒක මගේ ray diagram එක ඇඳපු විදියෙන් පොඩක් වැරදි විදියට ආවේ ඒක. But it's actually supposed to be like that. Did you get what happened here? So initially when I drew the ray diagram, ray diagram එක නිකන් straight lines ඇඳහම මේ හරියනේ meet උනේ. But here there was a little error. Errors චූටි රේක වුණත් sometimes can affect a lot when you take the position of the image and the size of the image. Okay. So because of that error එක මේ හරි හම්බුනේ, but හරිනම් F dash වලම තමයි meet වෙන්න ඕනේ. So object is on F dash on this side of the lens. Image is on F dash but on the other side of the lens. Is it clear? Did it get confusing or is it clear? If it's clear, give me a thumbs up. Oh, good, no? Okay, අපි චුට්ටක් බලමුද මෙයාගේ size එක කොහොමද කියලා. මෙයාගේ height එක නිකන් මෙන්න මේ ගාන වගේනේ. I was trying to measure the height. So object එකේ size එක around this much, no? Let's check if that same size you can see in the image. Image එකේ yeah, around that same size. So object and image are both the same size, okay? So location, we'll rewrite this again. On the point that is twice the focal length on the other side of the lens. Then properties, now properties change a little bit. It's still a real image, it's still an inverted image, but it's not smaller than the object, it's the same size as the object. Is this clear to you, Lamai? Give me a thumbs up. Okay, now draw then. I will set a timer for 5 minutes quickly. Okay, Laman. Shall we move on to the next one? Give me a thumbs up if you have finished drawing this. All right. Then last one, fifth one. Object is beyond twice the focal length. Make time mang draw kar pe kenne. Copy this. Okay. So this is my convex lens. And let me mark focal points. Let's place this nicely. Okay. Okay. So F is here. F is here. F dash is here. And F dash is here. Now the object is beyond twice the focal length. Earlier the object was on F dash. Now it's beyond F dash. Let's say like somewhere here. This is where our object is. Okay, now as usual, we will draw the ray diagrams. Our first ray diagram, as I said, from the basic ones, you can use two. Optical center ka through yane kena a path ke mayanawa mehema. Then perpendicularly on a light ray perpendicularly parallel. Parallelly on a light ray focal point through refract. That seems right. Where do they meet? They meet here. And this is where the image is. Much because object looks very ugly. Oh no. Give me a second. Chuptak make a straight draw and try can overall lamai rule ka use color draw karanda. Okay, like this. So here location of image is between focal length and twice focal length on the other side of the lens. Then properties, it's a real image, it's an inverted image, and it's a diminished. Now this is diminished, smaller than the object. Is this clear, Lamai? Give me a thumbs up if it's clear. Others? Okay, shall we quickly draw this as well? Make it fast. I will set a timer for 5 minutes. Make it fast, really fast. Done, lamai? Give me a thumbs up if you have finished. Okay. Now we are going to do a little activity. We are going to see how, if you are given like randomly, if you are given a convex lens, how can you do an activity to find the focal length of this? Do you remember last week or so we did an activity to determine the focal length of a concave mirror? Do you remember that? Where we like kept the mirror in front of a window and we focused a distant object onto a white screen. Do you remember that? No? Okay, Mihaly remembers. What about others? Others don't remember? Metna also remembers. Evindi remembers. Metmi remembers. Tinura remembers. Okay, good. Ashwita remembers. Right. So here, make a ogata can patangana kalima ඔගලන්ට එක අන්ඩර්ස්ටෑන්ඩ් කරන්න ලේසි වෙන මං කියන්නම් මේක එකම කතන්දරේ. අරක වගේම තමයි මෙතනත් වෙන්නේ. So just imagine now here in tray number 2 in image formation 2 අපි කිව්වා when the object is on the focal point image will be at the image will be at infinity. So what will happen if the object is at infinity? Make an opposite එක උනොත්. If the object is at infinity, where will the image be? Yes. Actually, yes, at the focal point. When the object is at the focal point, image will be at infinity. In the same way, if the object is at infinity, image will be on the focal point. Okay. So, මෙහෙමයි දැන් activity එක කරන්න මුකුත් ලියන්න එපා because I'm going to change the note, but just listen. So, I'm going to consider an object that is window එකක් තියෙනවා. window එකෙන් එළියේ there you need to like see a distinct object. නිකන් ගස් ගොඩාක් තියෙන forest එකක් වගේ පෙවුනොත් එහෙම ඔයාලට image එක ගන්න අමාරුයි. එක ගහක් වගේ තිබ්බොත් it's easy to focus the image, right? Or like one tree or one building වගේ distinct object එකක් තියෙන්න ඕනේ. Samaning, this works very well if it's a sunny day, but if it's like a gloomy day or if it's like an evening, මේක ගොඩක් වෙලාවට වැඩ කරන්නේ නැහැ. So if it's like අර හරියට දවල් 12 එක වගේ තියෙන අවුව වෙලාවක වගේ මේක කරොත් this works. Okay? So this is the object that you can see out the window. And inside the lab or wherever you do this, we have like a small table. මේ table එකේ මම මගේ lens එක stand කරලා තියෙනවා. I use a lens stand for that. අර mirror එක stand කරා වගේ කලින් activity එකේ I'm going to stand the lens. So that it's easy for me to move the lens and hold it. Now, as I said, if the object is at infinity, image will be on the focal point. And it's going to be a real image, so I'm also going to use a white color screen. I'm also going to use a white color screen. Okay. Now what I'm going to do is, object is there because the object is quite far. The object is ගොඩක් ඈතනේ තියෙන්නේ. ඒක හින්දා මම assume කරනවා infinity කියලා. But it's not actually infinity. ඈත තියෙන හින්දා මම infinity කියලා assume කරනවා. දැන් මම මොකද කරන්නේ? lens එක මෙහෙම තියලා මම මෙහෙම white color screen එකේ එහාට මෙහාට move කරනවා. ඒත් මට හරියට image එකක් ආවේ නැත්නම් මම lens එකක් චුට්ටක් එහාට මෙහාට move කර white color screen එකත් එහාට මෙහාට move කර I stopped at the point where you can see an image of that tree, but it's small and it's inverted. smaller and it's also inverted, but you can get it onto a white color screen. That means it's a real image, right? So this is the object which we assume that to be at infinity. Ne? ඒතර image එක හැදෙන්නේ focal point එකේනේ. එහෙනම් this will be the focal point of the lens. Then you can measure this length or this distance between the lens and the image. Image එක තියෙන්නේ white color screen එකේ. And this is the focal length, simple F. Is this clear to you, Lamai? Others? Okay, then අපි මේක ලියමු. So put a subtopic first. Convex lens. Huh? නෑ මාත් එක්කම draw කරගන්නවද? You put the topic, no? So මාත් එක්ක මේක draw කරගන්න. I'm not going to change anything here. So මාත් එක්කම draw කරන්න. Okay, Lamai, quickly write this. Draw and write this faster. Done, Lamai? Others?
Yes, teacher.
Mm-hmm.
Teacher, next week will we start waves?
Yeah. So seems like today we will not be, let's see, concave lenses වල එක ray diagram එකයි තියෙන්නේ and yeah, we will, let's see, somewhere I will චුට්ටක් නිකන් first page එක වගේ just because I said I will start waves, we will do like at least one paragraph or something. Okay, anyways, so I think this is clear. We can move on to concave lenses. Can you put the topic, please? Concave lenses. 9, 10. Let's see. Okay, Lamai. So concave lenses, Vala. If you remember, when we talked about convex lenses, we said that convex lenses are formed by the combination of two imaginary spheres. They are not real spheres, they are imaginary spheres. We can understand how a convex lens might have formed using these two imaginary spheres. ඒ වගේ concave lenses වලට imaginary spheres දෙකක් තියෙනවා, right? So this is how it looks like. Don't draw anything. Make an imaginary sphere එකක්, මේ අනිත් imaginary sphere එකක්. Like that. So this is center of first imaginary sphere. This is center of the second imaginary sphere. Okay. And our concave lens is between these two imaginary spheres. So this is our concave lens. Concave lens. Okay. When you draw a line connecting the two centers of the imaginary spheres, the line we get, we call it the principal axis. Our convex lens we call this principal axis. And exactly the midpoint of this lens we call the optical center. Optical center. Is this clear, Lamai? Give me a thumbs up. Okay. So here, just like I'm not gonna write anything here because it's more or less the same thing, right? Again, principal axis මොකක්ද කියලා දන්නවා, optical center මොකක්ද කියලා දන්නවා. I will just put one sentence here, but before that, let me explain one more part to you. In convex lenses, we learned about the focal point, right? Let's talk about the focal point of concave lenses. So let's say we have the principal axis like this, right? And this is my concave lens. To show that this is a concave lens, I will draw the shape of the concave lens like this. Okay. Now, this is how you identify the focal point of a concave lens, right? What you do is you send a parallel light ray to the lens. Parallel light ray. Okay. If it was a convex lens, light ray ඇතුල් පැත්තට තමයි refract වෙන්නේ. However, in concave lenses, light rays හැමලෙම ඇතුල් පැත්තට නෙවෙයි refract වෙන්නේ එළිය පැත්තට. Right? So this light ray will refract like this. Now we have a little problem. If you remember, in convex lenses, කලින් ඉගෙන ගත්තා convex lenses වල මෙහෙම parallel light එකක් ආවම එයා මෙහෙම refract වෙනවා the point where it meets the principal axis we named it as the focal point. But here now this is different now. Why is this different? Because now the parallel light ray, when it is refracted, it is going outwards. It is refracted outwards. So it will not reach the principal axis. How do I determine the focal point? Right? So refract with a light ray, you are going to extend it backwards. Like this. And the point where it meets the principal axis, I label this as F because this is the focal point. So if I show you another one, I'll send another like a parallel light ray like this. It will also refract outwards as if it is refracted from the focal point. Focal point එකෙන් refract වෙනවා වගේ එළිය පැත්තට refracted. That is how concave lenses work. Is it clear? Give me a thumbs up if this is clear. Thumbs up. Okay. Let's write a little bit. Okay. ළමයි මේ උඩ තියෙන diagram එක draw කරගන්න. Okay, quickly write this, make it fast. ළමයි, I'll give you like 2 more minutes. Quickly finish. Huh? මේ යට diagram එකක් draw කරන්න ඕනේ. Focal point එක කොහොමද determine කරන්න කියලා. Done, ළමයි? Give me a thumbs up if you have finished. All right. That is, so then in concave lenses, we are only going to be talking about one image formation. අපි basic reflections ගැන කතා කරන්නෙත් නැහැ because එකක් තමයි මෙහෙම parallel යන එක්කෙනා outwards refract වෙනවා as if it is being refracted from the focal point. අනිත් එක තමයි අර convex lenses වගේ optical center එක through යන එක්කෙනා ඒ path එකේම යනවා. So, put a subtopic image formation. Put a subtopic image formation. Okay. All right. So, what object එක ඕනෙම තැනක තියන්න පුළුවන්. Right? Wherever you keep the object, image will be the same. So I will just randomly keep, you can keep the object anywhere, okay? So I will just keep the object here. Like that. So what are the light rays that I'm going to use? එකක් තමයි optical center එක through යන කෙනා ඒ path එකේම යනවා. See? Optical center එක through යන කෙනා ඒ path එකේම යනවා. අනිත් එක තමයි parallel යන එක්කෙනා, the light ray that is going parallel will refract as if it is being refracted from the focal point. Focal point එකෙන් refract වෙනවා වගේ එයා මෙහෙම refract වෙනවා. Like this. Focal point එකෙන් refract වෙනවා වගේ refract වෙනවා. Did you understand up to that point? Did you understand up to that point? Optical center එක through යන කෙනා ඒ path එකේම යනවා. Parallel යන කෙනා focal point එකෙන් refract වෙනවා වගේ outwards refract වෙනවා. Okay. So this is one of my refracted light rays. This is my other refracted light ray. Are they meeting at the front of the mirror? Sorry, lens. Are they meeting? Are they meeting at the front of the lens? No. Why? Because they are going far and far apart from each other. එහෙනම් වා මොකද කරන්නේ? දෙන්නවා පිටිපස්සට extend කරනවා. So මෙයාව extend කරාම මෙහෙම, මෙයාව extend කරාම මෙහෙම. And we can see At the back, the two light rays meet. එහෙනම් මෙන්න මෙතන තමයි image එක හැදෙන්නේ. And the image is on the same side as the object. So we call this image a virtual image. That's why I have used dash lines to draw. Okay. So may refracted light ray ke පිටිපස්සට extend කරා. May refracted light ray ke පිටිපස්සට extend කරා. And this is where they meet. And that's where we have the image. So that means when you keep the object, you keep the concave lens. Through the lens, you can see the image. But what will be the properties of the image? What will be the properties of the image? Alamai, what will be the properties of the image? It is a virtual image. Yes, what else? It is smaller than the object, so we say it's diminished. And yes, it will be upright. Okay, yes, correct. Is this clear to all of you, Lamai?
Yes, teacher.
All right, quickly draw this. Quickly draw and write this. Make it fast.
Teacher done.
Okay, let's wait for others to finish. Done, Lamai? Okay. So there's a little section that is remaining. අපි ඒකත් ඉවර කරලාම අද wrap up කරමු නැත්නම්. Okay. So the next part, put a subtopic. Hand lens, magnifying glass, hand lens, magnifying glass, or simple microscope. Lamai, for a simple microscope or for a hand lens, we are actually using a convex lens. Okay, we are using a convex lens, not a concave lens. Harida. Then, my kata. Okay. So first of all, this is my principal axis. This is the lens. Like this. Focal point. F dash. Then here I have my focal point and F dash. Let's first look at, we all know what a magnifying glass is, right? Magnifying glass and some of you may have even used one. Magnifying glass hand lens and sometimes we call it a simple microscope. Let's first talk about the properties. In a magnifying glass, do you get a real image or a virtual image? What do you think? Real or virtual? Since you have the experience of either you using or you may have seen somebody else use, what do you think? Okay, Mayundi. Others? Others, what do you think? Real or virtual? Okay, Miheli. Okay, Metmi. Okay, Tinura. Okay, Risindi.
Virtual.
Okay, Ashvita. Do others also agree? So, if it was a real image, yes, Metna. If it was a real image, we would need a white color screen. But generally, when we're using a magnifying glass, we don't use a white screen because through the glass, we can see the image. Through the glass, through the convex lens, image it is a virtual image, not a real image. Then, as you know, in a magnifying glass, do we get an upright image or an inverted image? Upright or inverted? We get an upright image. Yes, good. Yes, Mayundi. Yes, Sevindi. Yes, Miheli. It's upright, not inverted. Because and with magnifying glass ke in the glass pain. Have upside down right? So we get an upright image. Do we get a magnified image or a diminished image? Yes, met me. Yes, Metna. Yes, Tinura. Yes, Miheli. Yes, Sevindi. It's magnified. Obviously, that's why we're using a magnifying glass because we want to see a larger image, right? So we are getting a magnified image, not a diminished. May properties tunama match nang, where should I position the image? Because we have learned a few ray diagrams, right? Image between the lens and focal point like this. Sorry, object. Object on the focal point between F and F dash on F dash beyond F dash but matching these properties of the image, where should I position the object? the positions which position produces a virtual image?
Between F and F1.
Okay, Ashwita says between F and F dash. Others? Mayundi agree. Okay. No. Mayundi again no. Miheli agree. So you think the object should be between F and F dash? Okay, Mayundi. Mayundi says C can A optical center and F. Methna also says lens and F. Okay, now I'm getting two different types of answers. කට්ටයක් කියනවා lens එකයි focal point එකයි අතරේ. තව කට්ටයක් තියෙනවා F and F dash අතරේ. We'll see. අපි උඩ draw කරානේ F and F dash බලමු. Here. If the object was between F and F dash, image would be a real image. It would be magnified and it would be inverted. Real, inverted, magnified. අපිට ඕනේ real image එකක් නෙවෙයි. Inverted image එකකුත් නෙවෙයි. Magnified නම් yes. But මේ දෙක match වෙන්නේ නැහැ. එහෙනම් if between F and F dash is wrong. Then I got another answer between lens and F. Let's see that. Here, no? Object is between the lens or between the optical center and the focal point. If the object was between the lens and the focal point, image would be a virtual image. It would be upright and it would be magnified. Virtual, upright, magnified. බලමු ඒකද අපිට ගැලපෙන්නේ කියලා. Virtual, upright, magnified. Yes, ඒක තමයි අපිට ගැලපෙන්නේ. එහෙනම් අපි image එකකුත් object එක කොතනද තියන්න ඕනේ? Between the lens and the focal point. Is that clear to you, ළමයි? Give me a thumbs up if that is clear. Others? Okay. එහෙනම් ඉතින් අපි අර usually ඉගෙන ගත විදිහම ray diagram එක draw කරන්න තමයි තියෙන්නේ. Optical center එක through යන කෙනා ඒ path එකේම යනවා. Parallel යන එක්කෙනා focal point එක through refract වෙනවා. Like this. Then you extend them backwards. Let me zoom this in a bit. So you extend this like this because they don't meet at the front of the mirror. Sorry, front of the lens. So I'm going to extend this backwards like this. And we can see they meet here. Since the image is on the same side as the object, it's a virtual image. So this is the image, this is the object. Is this clear to you, ළමයි? Yes. Okay, start drawing. Okay, ළමයි, quickly draw and write this and let me know when you're done. Let me know when I'm done, lamai. Okay, lamai. So, last week's whiteboard note also I will send. Today's whiteboard note එකත් මම එවන්නම්. This is the last week of March, no? So, next week we will be meeting in April. April first week එකේ මම ඔයගලන්ට LMS එක introduce කරනවා. So, පළවෙනි week එකේ විතරක් මම link එක WhatsApp එකේ එවන්න කියනවා Miss Divyaට, but after that the link will be every week it will be uploaded to the LMS. Every day it will be a new link, right? And also before launching the LMS, if you have any pending fees to settle from this month or previous months, kindly settle that because in the future I think LMS එක arrangement එකක් තියෙනවා මම ඒක හරියටම කතා කරලා next week ඔයගලන්ට කියන්න. That's basically all I have to say. Any questions that you have from what we did today, or any questions in general, or is everything clear? If everything is clear, give me a thumbs up. Others? Others? Okay. Then lamai, let's wrap up. Let's meet next week on 4th of April. So until then, have a great week and good night. Okay.